Okay, so I'm going to be going over the Unit 11 3D review. This is going to be our last unit test for the year, so that's good. Okay, so number one is talking about cross-sections. So cross-sections are when you're taking a 3D shape, you're slicing it, and then looking at what 2D shape is formed after the slice. So like if we were to take a cone and slice it horizontally and look at that slice, and you can kind of even see in the picture, that slice is going to be in the shape of a circle. Okay. If we were to take a cube or a rectangular prism and slice through that, okay, then the 2D section, the 2D slice would be like a square or a rectangle shape. And then here we've got a hexagon, and so if we were to slice through, that 2D shape would also come out as a hexagon, mimicking the shape of the base. And then it's not on here, but I just want to point out that if you were to, for example, slice a cone horizontally, or sorry, vertically instead of horizontally, and then look at that slice, the slice that was vertical would look like a triangle, okay, right? Because you can imagine if, like, here I've got this half of the cone, okay, and that's going to come out looking like a triangle. Okay. All right, number two. List the names of the 2D figures that make up each solid as well as how many you need. So this figure right here, this is a square pyramid. Or we could say rectangular pyramid if we weren't totally sure that this was a square. And then there's one base, and that's in the shape of a square. And then it's got 1, 2, 3, 4 faces, and they're in the shapes of triangles. This shape here, so this has a triangular base. Remember, bases are defined by what two shapes are parallel, not by what you're sitting on. Okay, so this is a triangular prism. It has 2 triangle bases, and then 1, 2, 3 rectangle faces. Okay, number 3. It says identify the 3D figure that would be formed if the 2D shape was rotated about the line. So you have to imagine that this line is like spinning around, you know, and around and around, okay? And this 2D shape is also getting spun, okay, and rotating around as this line rotates. So, for example, this corner would come around to this side and rotate around like that. And then each one of the points on this line would also be rotating around. Okay. So as it rotates, you see that the 3D shape that begins to form is a cone. Okay. For the next one, if this half circle were to rotate around, again, like, it's kind of hard to draw, but like this, and we're kind of rotating and rotating. Okay, so that forms a sphere. And last, if this rectangle were to rotate around, remember this point is going to rotate around in a circle, okay, same as this point. So it ends up forming a cylinder. Okay. All right, so now we have a couple surface area problems. These are very important problems to know, okay? And they're going to be worth more than the regular amount of points on the test. These are worth about 6 to 8 points each. So just keep that in mind when studying tonight. Okay, so first, I want to get the total surface area. This shape is a prism, and the surface area for prisms is pH plus 2b. P stands for perimeter of the base. B stands for area of the base. Your base is this triangle right here. Okay? Okay. So if we're going to get the perimeter and area for this triangle, we need to know what these other two measurements are. We're going to use SOHCAHTOA to do that. So let me extend this a little. So we have this 30-degree angle, okay? The side that we're given is the hypotenuse, and let's say we want to solve for this side right here. Okay? So this side is across from our 30-degree angle, which makes it our opposite side. If we're given our hypotenuse and we're solving for the opposite side, then the ratio we want to use is the one that has opposite and hypotenuse. So that goes with sine. Okay? So then we're going to take the information that we have here and plug it into this proportion. Sorry. Okay. So here's what that's going to look like. So we have sine of our angle, which is 30, is equal to the opposite side, which we don't know, we're trying to solve for, over the hypotenuse side, which is 8. Sine of A, opposite hypotenuse, so sine of 30, opposite hypotenuse. Okay. All right, once we get to this step, we need to get x by itself. So the way that I would do that in this case is I would multiply by 8 on both sides. Those cancel, and you have x is equal to 8 times the sine of 30. Ooh, don't forget to make sure that your calculator is in degree mode. So like if I were to reset this, okay, the default mode is in radians. To take it off of radians, you go down, go over, and you need to press enter so that it unhighlights radian and highlights degree. And then you can hit second mode to get out of there. So 8 times sine of 30, and that's equal to 4. Okay. All right. So once we've got that this is 4, you could use SOHCAHTOA again to get this side, or you can use Pythagorean theorem. So I'll show you the Pythagorean theorem. This is our hypotenuse, this is the leg, we're solving for another leg. So we would do the square root of 8 squared minus 4 squared. Okay. And that would be about 6.9. Okay, now we're ready to get all of our stuff for our surface area. So our P would be equal to 8 plus 4 plus 6.9. So that would be about 18.9. Area of the base is going to be 1/2 BH, since this is a triangle. This is the formula for area of a triangle. So that's going to become 1/2 times 6.9 times 4. So we get 13.8 for our area of the base. And now we can go plug everything in. So we have 18.9 times this h stands for height of the prism, which would be 8, plus 2 times area of the base, which is 13.8. So typing that in, 18.9 times 8 plus, parentheses, 2 times 13.8, we get 178.8. All right, so for this problem, I'm going to solve it the way that you would be expected to solve it on the test, which is not going to include the bottom. Okay, so do not include the bottom or the part that sits on the ground. Okay, so there's more than one way to solve these kinds of problems. What some students like to do is they'll find the total surface area for this cylinder and this cylinder, and then just subtract out whatever you don't need. So the issue is that we don't want to include anything that's not being exposed to the surface in this picture. So like there's a base here that's a part of this cylinder that this is not exposed. Okay? So if we're doing total surface area, then we would want to take that out. And then also, if we're not going to include the bottom, okay, then if we were to find total surface area of this cylinder, we would want to take that out. Okay? And then in addition, when you do total surface area of this bottom cylinder, don't forget that not all of the top is showing. So you would also want to take out this little base from the total surface area of the bottom cylinder. Okay. All right. Now that's if you're doing subtraction method. I prefer to do it in terms of thinking about what I'm adding up. So if I think about what I'm adding, sorry. Okay. So the first thing is that I'm going to have this top circle. Okay. So I'm going to put TC for top circle. Then I'm also going to include this lateral part of the little cylinder. So I'm going to do lateral of, let's say lateral of top cylinder. Okay. I've got this partial stuff that's showing. So partial of the bottom cylinder. Okay. And last, I want to include the lateral stuff of the bottom cylinder. So there's 4 things that at the end that I need to have calculated so that I can add them up. So first, for the top circle, okay, area of a circle is pi r squared. Our radius for this is 4, so that's going to be pi times 4 squared. Okay. And we get that that's about 50.27. So I'm going to circle that because that's one of the things I'm going to have to add at the end. Okay. Next, we want the lateral for this cylinder. So a lateral for a cylinder is 2 pi RH. Okay. So plugging that in, 2 pi times my radius is 4. Height is 3. Okay. So we've got 2 pi times 3 times 4, or 4 times 3. So that's about 75.4. Okay. For the partial stuff, I'm going to need to find the area of the big circle and subtract the area of the little circle, and that'll give me all of this stuff that's exposed. So the big circle would be pi r squared, and in this case our radius would be 10, okay, for the big circle. So that would be pi times 10 squared. And then for the little circle, our radius is 4, so I would want to subtract pi times 4 squared. Let's speed this up a little bit. Okay, so I've got pi times 10 squared minus pi times 4 squared. You can type it in just like that. And we get that that's about 263.9. Okay. All right, so I've got 1, 2, 3 things, and then the last thing I need to add is the lateral of the bottom cylinder. Okay. So once again, our formula is 2 pi RH. In this case, our radius is 10, and our height is also 10. Okay. So 2 pi times 10 times, 2 pi times 10 times 10 is equal to about 628.3. Okay, and that's the last thing that I'm going to need to add. Okay. All right, so because my work is nice and organized, and I circled everything that I'm going to need to add at the end, it's easy for me to go in and just add 50.27, 75.4, 263.9, and 628.3. Okay. 50.27 plus 75.4 plus 263.9 plus 628.3. And we get that this is about 1017.87. Yeah. And that's our total surface area. Okay. All right, so I'm going to stop the video for the front side, and then I'll continue the back side in the next video.